Hello everyone, welcome back to RCH Builders. So last thing that we saw in this room was putting down the flooring. Had to move some of the stuff from the other rooms into here so we could continue in there. So that's kind of a mess. We've got it on top of a mover's blanket mostly to help protect the flooring. But we've gone ahead and put the baseboard in here. So the trim is in place. Still needs to be painted. However, on camera, it pretty much looks like it's painted. Anyways, the next step that I'm going to go ahead and take care of right now is we're going to be putting in all of the electrical. So when I did the painting, I put in all of the louvers up here in the ceiling. And so we have light. Also, previously, we've had this temporary outlet that we've been working with. I just simply put it back in the wall, put a cover plate on it, and we got our temporary switch for these lights. I am going to leave the lights on and the breaker on until I get to this outlet. So, of course, you don't want to be doing this with the electricity on. That is one of the biggest safety things they're going to teach you. But what you can do so that you have light in the meantime, makes it a little bit easier to work with without having to try and maneuver a flashlight, is if you're the one who ran this circuit and you know exactly how it is ran, then you can run everything backwards until you get to the last outlet where there would be power. So the way I ran this is when I came from the panel to the switch, and then I ran around the room this way. So what that did is two things. One, it allowed me to have power at the switch for light, and I hooked up this outlet being the first one where it comes to, and with it being hooked up fully, over here we have wire nuts capped on top of the wires coming from this direction. So it's capped right there, but with that being the case, everything this way, even though the breaker is on, is dead. So it's something that I always do, even if the breaker is off, just in case, say, you got somebody working with you, like y'all seen plenty of times. I got Tyler with me a lot of times. So in case for some reason he's working in another room, goes to turn on the breaker in there, and while he's turning that breaker on, so he can test out what he has done, he might accidentally, because it's easy enough to do, accidentally turn on the breaker for the room I'm working on. With that being the case, even though the power is supposed to be off to it, I still run it in reverse like that so that I don't have to worry about if he accidentally does that. Not until I get to the last outlet. And then I can go double check before I work on that one outlet, which is the only one that will have electricity until it gets hooked up. As soon as it gets hooked up, it's going to run it all downhill through the rest. But that is one way to be safe about it without having to worry about whether the breaker is on or off. Anyways, of course, you have lockout tagout systems you can do, but most homeowners, you're not going to have a lockout tagout system because you're usually working by yourself. There's no point in it. And in smaller companies, a lot of smaller companies are not going to have it either because they only got one or two guys, and if they do it, it will help with their insurance purposes and stuff like that. But I have worked for many, even large electrical companies who have not had lockout tagout systems. But anyways, this is a way for you to be able to do that, to be able to wire it without worrying about it. Only when you get to the last outlet, it doesn't matter. Anyways, so I'm going to go ahead and get started with this, and then we'll go from there. So this is the very last one on the circuit, so of course there is only one set of wires. This is 14 gauge wire. It is protected by a 15 amp breaker. And with it being 14 gauge by code and by manufacturer specifications, you could push it in the back holes right here on the outlet. I've seen some people try to put number 12 in here, where I've had to go in and work on fixing stuff. I've seen some people who put number 12 there. By manufacturer specifications, those holes are only for number 14, not for number 12. However, even though this is 14, I never put them in the back. The reason being is because it is operated through a spring-loaded system, which is metal, which heats up and contracts, and over the time, everybody knows springs get loose. Instead of tightening down a screw, which to me is a lot safer. So, white, of course, hooks up to the silver. Your ground is going to hook up to the green, and then when you flip it over, your blacks will hook up to the copper. And I always tighten down all screws, even if there's no wire on it, going in it. It just helps make sure you don't have a loose screw. Also, it gets the screws tighter up against the outlet, so you don't have to worry so much about something touching it. I'll pay attention to how you curl the wires up inside the box. See if I can get this here. You want to make sure that the ground wire, because it is bare, is maneuvered in such a way that when you push the outlet in, it's not going to end up coming up and touching either of either the neutral or the hot screws. It's not real difficult. It's just something to pay attention to. I've had to go through a lot of times with some people, different people working for me, where I have had to figure out why an arc fault breaker is tripping or something, and a lot of times when it's a brand new circuit, it has to do with simply the way they put the wires in the box, and that ground is touching one of those screws. So, like I say, always just pay attention to the way you do it, and then you'll never have that issue. Then I'm going to move on to the next one. The next one is going to be exactly the same, except for the fact that it is going to have two sets of wires. And so we will be putting a wire on both of the sets of both of the screws. And I have, let's see, counting this one, there are 3 more that I will do that will be exactly the same as far as this goes. When you cut these off, I always cut them off a little bit, get rid of some of the crookedness. Make sure you're still maintaining the code requirement from where the wire enters the box, which is 8 inches as far as how much wire you have. I've done this a lot, so I know basically what it is. Also, my hand is exactly 8 inches, so it's like 7 3/4. But either way, as you can see, it's coming past there about 3 inches. So I don't like to go with the bare minimum. It just makes it a lot harder to work with, especially if you ever have to come back and do any work on this receptacle. So giving yourself that little extra helps, but you don't need what was there, which was probably closer to 12 inches, an entire foot. So you want to maintain a nice little balance between having enough to meet code, not too little, but also not having so much that it ends up, when you're trying to push it back in the box, very difficult to not end up getting this ground pushed in there in a weird way where it does hit a screw. So, like I said, basically it's the same. I always turn the wires with the wire stripper upward like this, as you can see. And then I start with the receptacle on the neutral side. That allows, when I hook it to there, it turns the same direction as the screw, so that as the screw tightens down on the copper, it tightens that loop. If you put it the other way, when you tighten the screw, it will actually open the loop, making it harder to stay under the screw. It basically backs it out. So instead, I'm going to do 2 more after this, exactly the same, and then I'm going to add 1 more step to the last few, and I'll show you that when I get to that part of it. Alright, so the part that is different about this receptacle and the other one, and the last one, is the fact that these are mounted on a cinder block wall. The others were in the addition, so they're on where there are wooden studs, and they are in a plastic box. However, with these being again on a cinder block wall with some furring strips to be able to run the electrical through there, it is in a metal box. Now, this is not a requirement. This is simply something that I do as an added protection. Because this is a metal box with a metal plaster ring here, the metal box is grounded with the ground wire through a ground screw in the back. It's right there, that little green screw right there. So, with that being the case, all it takes is, say, for this screw that holds this to the box to break at some point, which can happen. And if that happens, then when someone tries to plug something into here or pull it out and they wiggle it, they can easily make one of these screws hit the side of the box right here, which is metal, grounded to the ground, and blow the circuit, have sparks go flying and everything, of course, you know. And so by wrapping electrical tape around it, it helps protect against that happening. So it's not required, it's an added feature that I usually only do in metal boxes. In a regular box, there should not be any issues with that. Usually if the ground wire gets in a position to where it's going to touch a screw, even if you wrap electrical tape around the device, it a lot of times will poke through the back side and still touch. So there's not much point in doing it there as it is right here. This is more to protect from the side of the box, not from the actual ground wire itself. Alright, so from there, I have one more outlet to do, but it is the one that has the power going to it. So I'm not going to do that one just yet. I have that one, and I have, of course, the 2 switches to put in over on the wall. I got to put the actual switches in instead of the temporary. But when I do that, of course, I'm going to turn the electricity off. However, because we don't have the switch in for the fan, the temporary one's for the lights, I'm going to go ahead and hook up the ceiling fan, put that in real quick for y'all while we still have light. And then we'll do the stuff that requires having the electricity off. All right, so for a ceiling fan, the minimum height to the bottom of the blades is supposed to be 7 feet, 84 inches. Usually you would like it to be even higher than that, but 7 feet is minimum height that you're allowed to do it. You're not supposed to go any lower than that. And that is to protect people against hitting their hands. And you've probably noticed, of course, how easily I can touch the ceiling in here. I mean, arm completely bent. The ceiling in here is actually 8 foot 2 inches. So with that being the case, we have 2 inches to work with as far as not being too low. However, with that being the case, no ceiling fan, flush mount type or anything is going to be 2 inches from the ceiling. So with that being the case, you have to go with a different style fan. Now what the homeowners have picked out is one right here, which I'm going to be installing, and it is completely encased. It is below the minimum requirement height. It basically needs to be just like a cage fan on the floor, something that protects your fingers from getting chopped and hit by the fan. With that being the case, this is a very different style fan than normally is being put on the ceiling, but that is the reason why it is like this in a cage, a very different style. It has to do with the minimum height. They wanted a fan to help move the air, but they do not have the height to go with a standardized ceiling fan. I guess they expect my wife to come out here and install this ceiling fan with me. They give me these nice white gloves so I don't get the ceiling dirty. First thing we're going to do is mount the mounting plate. This fan weighs absolutely nothing. I mean, literally, I'd be surprised if it even weighed 10 pounds. It's all plastic, even the blades. But we do have a fan rated box in, and that's what we'll be mounting this to. That way, if they ever change to and find a heavier duty style, the same type, then they will be set up for that. Has a hook to be able to put a safety cable on there just in case it was to ever fall. A lot of times when you have a fan with a remote, you're going to have to hook up the receiver, but in this case, the receiver's already in it, already hooked up. So we only have to hook up the inline wires coming from the switch. These aren't going to really fit, but I'm just am trying to cover my fingers a little bit. Because any little bit of dirt gets on a white fan slash light super easy. And it's just going to push it in and turn it is the way that this one works until you feel it clip. And then after it's up there, I don't know if you can see, there's a small hole right around here. There are actually 3 of those going around it. And they've got these screws here, which seem a little bit long for this purpose to me, but that's what they give. The reason I think it's a little long is because it seems like it could possibly reach all the way through and touch the wire. So, but and that is the ceiling fan side up. And from there, the next step. Now we got to do the switch before we can actually test the remote and everything with it. So now we got to turn the electricity off. All right, so for the switches, I already know that this temporary switch that we had put in goes to the light. So this other set of wires that I have curled up in here go for the ceiling fan. Now the fan is on a remote. Also the fan, but with it having a remote, it needs to simply be installed with a standard switch. The can lights we're actually going to put on a dimmer so that they can adjust the lighting as they want to. But what I'm going to do is I'm going to go ahead and I'm going to hook up the regular switch first and put it in the box and get it out the way. Again, this is a metal box, so I will be taping it. And on a standard switch like this, it doesn't matter which one of these is the hot and which is the goes to the actual fan or light, because all this switch is doing is simply connecting the two together, so it makes no difference which one is which. Now we got to hook up the dimmer switch, and depending on the type of dimmer switch that you are using, if it is one that can be controlled by Wi-Fi or anything like that, especially, and there's a few other types as well. There's some lighted ones. You may need to have a neutral, and if that's the case, you would simply bring a pigtail off of the group of neutrals that are in the back of the box. But with these dimmer switches, these are the standard ones that they are. It is for LED, but it is there's nothing electronic in it. All it does is simply limits the amount of electricity going through it. So there's nothing super fancy on this one. No neutral is needed. And on most dimmer switches, the ground hooks up with a pigtail that is tied to the dimmer switch. So it'll be a wire nut instead of a screw. Now, also with the dimmer switch, you're going to need to, most of the ones there are now are either, can be both used as a single pole switch, which means that it only controls the light, or as a three-way switch, which is what this one is. So you'll have to look at the instructions to see which screws to use in a single pole scenario. On this one, it's these two bottom screws. You've got one over here, which is copper. This is what's considered the common. And so that's where you're going to want to hook up the hot wire, the wire bringing power, electricity to the switch. On most of these standard ones, it's not really a big deal. It's not as important for that to happen because you can actually have the light leg going here in a three-way scenario instead of the hot. So it doesn't necessarily have to be, but on some, the ones that have like Wi-Fi and all that, it is extremely important, even in a single pole situation, that you get the correct one going to the common screw. And the reason why is because when the switch is off in those cases, there will be no electricity feeding the switch for the Wi-Fi to contact and tell what to do. So, in this one, like I say, pretty simple. Again, on this one, I'm not going to try and wrap it with tape because there's no reason. You can see how the screws are, I don't know if you can see it. Should have been able to when I spun it around the other way. But the screws are sunk in, so there's an entire casing here keeping it from hitting the side of the box. Any of the screws, that is. So, again, we got to find our holes in the box because the mudding and paint is covering it up. And if you are dealing with a situation where you're putting multiple of these switches in the same box side by side, you will need to break off the tabs. There's little tabs on the side here. There's a spot you can see on it where you can, it's like it'll shear off. You can see this line right here. So these will break off, and you will need to do that if you're putting another one of these right next to it, or it won't fit side by side with a cover plate and all that. They break off real easy. I mean, this is very cheap, plasticky front piece on it anyway. I mean, I think it is technically aluminum or nickel, but it is extremely easy to break off right there at that shear point. And it goes for the same thing on the other side. So it works on both sides of the switch. And with these, they have a little dial here which will allow you to set how far down you want the light to turn when you dim it. Usually for LEDs, I will set it right in the middle. And because if you put it right in the middle, that allows the LEDs to dim pretty almost all the way down, but stay on enough. If you turn it all the way down to the minimum, a lot of times you can't even tell if the light is still on when it is on its lowest setting. And if you do that, you're apt to burn a lot of electricity that there's no reason to burn, because you'll think you turned the light off, but it is still on, running very small amounts of electricity, but still that adds up over time. And also the switch staying on 24/7 essentially, due to that, can make the switch burn up and go bad faster, because this is essentially, this dimmer switch essentially is a mini transformer to an extent, is the way that it works with regulating the electricity through it. So this switch does get warm. That is just by design. There's not an issue with that. I mean, it should not burn you to touch or anything, of course, but it will get warm because of the nature of how it works. And so you don't want that thing to just be on without you knowing it's on and just constantly running. All right, so now I just got to go hook up the last receptacle, and we can turn power back on and check out the fan. All right, so now we got the electricity back on. Let's check out the lights. Big difference there. So that's dimmed down, full brightness. Almost set it down there, just so we can see the fan easier. Turn on the fan. And this fan does actually have a LED light inside of it. And you're probably not going to, especially with it having plastic fins, you're probably not going to actually be able to see or hear the fan. But I can dim that light with the remote. It's actually pretty neat. Just hopefully it'll last long. You can also change the color. So I'm going to put it right around there, because that is pretty close to what the can lights are set on. Then we have, it actually has a, looks like it has a 2-hour timer. I'm going to put the fan on full speed. You can kind of very faintly see a little bit of movement in there. I don't want to get too close because of the, and I can hear that. I don't know if you can. It's actually, for a little bitty fan like that, it's actually moving some pretty decent air. I don't want to look straight up into it because of the light, and don't want to blind y'all. But yeah, so anyways, this whole room is ready, done with the electrical. Hope you enjoyed watching. I know the last video, I don't know, I didn't really like doing the last video too much, as far as the fact that I was needing to try and hurry up. I wasn't, in my opinion, wasn't able to set the camera up and give you a good quality video like I would like to do, where I actually maybe explain stuff, but even if I'm not explaining stuff, maybe I explain stuff afterwards, but then also you'd be able to actually see what's happening. So with that being the case, it's also kind of why last week I did skip a video, because I, again, didn't have a good video. I would rather not put out a low quality video. I'd rather be able to put the time into it to make a video like this that is more quality. If y'all like being able to, even if you can't see a lot, but you can see it somewhat, if you still were fine with last video, that's I guess, just let me know. I could always do those still in between if you wanted. And if so, I probably won't talk on those at all. I'll simply set the camera up in a corner somewhere, do what I got to do, and then, I mean, you'll see what you can see. Me, that's not the standard of what I'm trying to put out for y'all to see. So that is, you know, I myself was a little disappointed, but maybe y'all do like that. If so, let me know in the comments. Otherwise, I'm going to skip weeks like that, because I would rather take the time to put out something like this. So, hope you enjoyed watching, and I'll see you the next time.